speed, meth, ice, bless, crystal, crank are street names of methamphetamine, a dangerously addictive drug. Its use even in low dose damages dopaminergic neurons that are responsible for production of dopamine. These neurons play an important role in the control of brain functions, such as voluntary movements. Also are responsible for behavioral processes, such as mood, reward, and stress. Before going deeper in methamphetamine, subscribe to the channel, like the video, and leave a comment if this content is interesting to you. Methamphetamine and amphetamine are two important examples of stimulant drugs. Generally speaking, stimulant drugs speed up messages traveling between the brain and body, so make a person feel more awake, alert, confident, and energetic. Phenylethylamine is the core structure of amphetamine and methamphetamine and acts as a central nervous system stimulant. Amphetamine is a shortened form of methylphenylethylamine. From a structural point of view, amphetamine has an additional methyl group attached to the alpha carbon of the nitrogen. As you will see, this small change in the structures makes a huge difference. In 1932, scientists found that amphetamine can shrink mucous membranes, so amphetamine sulfate introduced to the market using the trade name benzedrine to treat nasal congestion. Within a short period of time, people found that amphetamine can be extracted from benzedrine. In order for government to reduce its destructive effects, abused using of benzedrine. But why are amphetamine and methamphetamine so powerful stimulants? Monoamine oxidase is an enzyme that is responsible for degradation of amine neurotransmitters like phenylethylamine. Both amphetamine and methamphetamine have a methyl group in the side chain, so they cannot split in active site of enzyme. It means that the enzyme cannot break them down, so they produce long-lasting effects. World War II is considered as a science war and a start of a collaboration between the military and academic researchers. When Germans attacked Portland in September 1939, they exhibited a new form of warfare called blitzkrieg or lightning war, which describes a surprising attack based on speed and shock in a way that the enemy cannot regroup. British newspapers had described German soldiers heavily drugged, fearless, and berserk. In The Art of War, Sun Tzu wrote that speed is the essence of war. Of course, he didn't have knowledge about methamphetamine and how it can make super soldiers. In 1938, Temmler, a German pharmaceutical company, introduced methamphetamine to the market under the brand name Pervitin. Soldiers could be alert all over the night and more aggressive during an attack by consuming Pervitin. After World War, consuming methamphetamine became widespread in society. People use it with heroin, a combination known as speedball. So methamphetamine started to be known as speed in the early 1960s. Due to synergistic effects, speedball is more powerful in the drug when taken alone. Now let's dive into synthesis. Methamphetamine contains a carbon atom with 4 different substituents, so it's a chiral molecule and exists as 2 optical isomers called enantiomers. Although these 2 isomers have identical properties such as melting point and solubility, they are different in interaction with receptors. The right-handed enantiomer has a stimulant effect and commonly known as speed. The essential challenge that the chemists face with it is the production of methamphetamine in an enantiomeric pure form. Ephedrine is a compound with very similar structure to methamphetamine. Fortunately, it is found in nature as a single enantiomer and can be used as a starting material. According to the literature, there are 6 routes to reduce ephedrine and produce methamphetamine. In this video, I focused on the route that Walter White in Breaking Bad series used to cook crystal meth, so it is familiar to you. The overall mechanism consists of 2 steps. In the first step, hydroxy group is replaced by iodide, presumably by SN1 mechanism. The mechanistic details of step 2 are strongly under-debated. In one of the possible routes, the carbon-iodide bond undergoes homolytic cleavage, leading to radical species. This intermediate can be stable due to stabilization character of the benzyl ring. Finally, the reaction is completed by single electron transfer, accompanied by oxidation of iodide to iodine, and methamphetamine is produced by abstracting the proton. But what is the role of phosphorus? As the reaction proceeds, concentration of the iodide decreases, so the reaction remains uncompleted. Phosphorus consumes the iodide generated in the second step and produces phosphorus triiodide and phosphorus pentaiodide, which hydrolyzes to phosphoric acid and phosphorus acid in the presence of water. As a result, iodide is recycled by reduction with red phosphorus, regenerating hydrogen iodide. At the end, it is interesting to note that methamphetamine as a free base is a liquid, but its salt is actually a colorless crystal, not blue as sculptured in the Breaking Bad. In order for a scriptwriter to differentiate Walter White's extremely pure crystal meth from other versions, it is depicted in blue. All of vector graphics you see in this video is designed by FreePic.